Welcome to my presentation on improving operations on a football stadium. Here is everything that I'm going to cover, beginning with the problem formulation and data modeling of the most important aspects covered, passing on to the effective model development and validation, experimentation and analysis, which essentially covers the main bottlenecks in the system as well as the approach used to target improvements, how the system can be improved, that is, the specific measures taken to improve operations, and some final remarks. So to begin, I'm going to talk about the problem formulation and conceptual modeling. The main problem needed to be tackled inside the system are the long queues, low fan satisfaction, and also low profit levels. So the goal is to find strategies to improve the operations of the stadium, in which the simulation and optimization approach will be used. Just to exemplify some of the problems in the current situation of the system, on the left is a graphic comparing the cumulative entrances to the stadium and the amount of fans inside the seating area, in which is clear that a good amount of them are in the concession at the beginning of the match. And on the right, the maximum amount of fans waiting in queue at each gate, which hits extremely undesirable values, especially on gate A. I will now talk a bit about the data modeling component of the problem. It is important to consider in the model the destiny of each fan depending on the gate that it enters. So as the graphics show, in gate A the majority of fans goes to the season ticket section, in gate B to the party section, in gate C to the general public and visitor sections, and in gate D to the family section. It was assumed inside the model that each fan entering the stadium goes to one of the three available services, and after finishing, to its designated seating section. So in this manner, it is important to consider the different probabilities across time for a fan to go to each service. After data modeling comes the most important part of the problem, which is the effective model development, validation, and also verification. After the entity, that is, a fan, passes through security and ticketing procedures, it is executed a process to send it to its designated entryway, with the probabilities shown just now. After getting to the entryway, it is assigned the section of each entity to a string variable, and a process is executed to send the entities to one of the three available servers. This process assigns to a node variable the proper destiny of each entity. Also, as I said earlier, the probabilities of going to each place inside the stadium vary with time, so another process is executed every 15 minutes that increments a counter variable in 1 each time in order to properly return the probabilities contained inside a table. This same logic is repeated for every entryway. After finishing using one of the servers, the entity returns and enters its section with the aid of a process that uses the string variable mentioned before. It is a simple process that works in a condition-based manner in which it sends each entity to its section depending on the content of the variable. It is also important to mention that sections are represented with sync blocks and entities exiting the seating area are created using source blocks with its respective rate tables, and the flow of these entities follows the exact same logic as the ones just entering the stadium. In regard to the quantities of food and shirts that each entity orders, those were made using simple state assignments. For challenge 3, which proposed an increase in beer sales if a goal was scored, two processes, one for each team, were executed in a fixed time interval, as goal attempts were assumed to be scattered equally through the match, and they had a probability of turning a variable into 1 if a goal was scored, or 0 if not. Afterwards, beer sales would increase or not based on a condition on the value of these variables, as it can be seen on the picture below. After developing the model, it is important to verificate and validate it, and so it was compared to historical data, the cumulative entrance of fans to the stadium, in which the results followed a nearly identical pattern. The average work in progress inside the seating area was also tested, and as it can be seen on the right, the results obtained were pretty close to past records, besides not knowing explicitly entities' behavior. Bathroom and merchandise entrances were also compared, with good results being obtained. The average error for individual servers was 5% for bathrooms and 9% for merchandises. As for total entrances inside all of the servers at once, the bathroom showed a 4% difference compared to historical data and 2% for merchandises. For concessions, results were also pretty similar to past records, with an 8% average error across individual concessions and 4% error for total entrances. For food and beverage sales, results were nearly identical to historical data, as it can be seen on the right. Here is a quick video showing the model operation, and as I said earlier, the entity arrives to the stadium and passes through security and ticketing servers, and after that, it goes to its designated entryway but does not enter the seating area immediately. Instead, it goes to one of the 3 available servers. In this case, this entity will go to merchandise 3, and after using it, it will go back and finally enter its section. So, as we are seeing here, the entity arrives, it is now using merchandise 3, and will finally return and enter its seating area, as we can see, and the counter will increase to 1 because there is one entity inside that section. After proper development and validation of the model, it is necessary to find strategies to improve its functionalities and operations. And so firstly, it is important to find the major bottlenecks that need to be addressed. In this regard, the amount of fans running from concession and merchandises is an area that has lots of potential profit left on the table, and so is a huge area of opportunity. The security operations also need to be addressed, as seen from the graphic on the right that indicates huge queues waiting to enter the stadium, especially on gates A and B. For the approach chosen, after identifying the areas of improvement, it is necessary to think about strategies to address them, applying those changes to the model, and finally, analyze the results obtained. So now I'll talk a bit about the specific solutions designed to improve the stadium operations. For the control variables used in the experiments and scenarios developed, those were the security and ticketing agents for each gate, the merchandise cashiers, and also the concession cashiers. The first measure taken was to develop a security express lane for fans that come to the stadium without bags, as was suggested on Challenge 2, and so maximum queue length was reduced by 86% on Gate A, 85% on Gate B, 76% on Gate C, and 73% on Gate D with a quick and simple solution. It was also designed an express lane on concessions for fans that want to order beverage items only. After experimentation, Concession 3 showed a good reduction in reneging and maximum queue length, which makes sense since the probabilities of fans not ordering food items in this concession is fairly high. For the rest of the concessions, however, operations were worse than in the base model. Lastly, operations with voluntary cashiers on concessions were also tested, as well as adjusted capacity to handle all incoming orders in concessions and merchandises. It was considered, however, that only half of the cashiers in each concession would be volunteers, since their availability could be scarce in order to replace all cashiers. By doing both those things, reneging from servers inside the stadium took a massive decrease and profits skyrocketed, as shown on the slide. Finally, after implementing all changes in one model, 4 scenarios were analyzed. 2 scenarios maximize operations and profit, one focused on operations but also a bit on profit, and the last one on profit with some emphasis on operations. For all scenarios, reneging in concessions and merchandise decreased a lot, and average maximum queue length decreased for all but the one maximizing profit. Service levels, which were calculated as the amount of fans inside the seating area at the beginning of each half, increased for the 2 scenarios focused on operations, but were a little worse on the ones focused on profit. As for total profit, it increased quite a lot for all scenarios. The scenario operations/profit seems like the most well-rounded one given total profit, improvements all across the board, and fan satisfaction. To sum everything up, just some quick remarks to end. As it was clear in the last slide, by implementing the changes proposed, stadium operations could vastly improve. It was also considered that the system capacity could be changed since it was the main reason behind the limitations in the stadium's operations, as a high amount of fans were reneging from queues. Lastly, one of the limitations of the model is that entities cannot go to 2 different services consecutively, which might not be very realistic, but since entities' behavior inside the system were not explicitly stated, this was the best assumption possible. Thank you all for your time and attention.